Hello, students. So, welcome to the fourth lecture of your chapter of physics, electric charges and fields. Till now, we have already seen that what are charges, types of charges, and what are conductors, insulators. Then we have learned about the properties of charges and analogy to it with like electrostatic force. We have learnt about that of Coulomb's law and its analogy with gravitational law. And after that, we have seen electric field and what is the definition of that, what is the use of that, and we have seen the properties of electric field lines. So these all topics we have covered till now, and then we have also covered some part of dipole. What is dipole moment and what is electric dipole, and also the calculation of electric dipole at axial point of any small dipole, and also at equatorial point of that dipole. So we will continue our discussion after that, which we have just covered in the previous lecture, and it was equatorial point we have calculated at that, and we will now continue to the example 2 of your chapter this book. So let's see that what is it saying. Two charges plus minus 5 microcoulomb are placed 5 millimeter apart. Determine the electric field at a point on the x on the axis of dipole 10 centimeter away from its center O on the side of the positive charge as shown in the figure A. Okay. So here, see here, we have two charges minus 5 microcoulomb and plus 5 microcoulomb. So they will form a dipole. Why? Because I have already told you that dipole is formed when two two uh, uh, unlike charges are there but of equal magnitude. So here minus 5 and plus 5 are unlike charges and of equal magnitude, and they are separated by a small distance. So we have to find what? We have to find electric field at a point on the x on the axis of dipole that is 10 centimeter away from its center. So it is a case of axial point. Okay, we have already covered this topic, that what is the electric field at an axial point of electric dipole. So here, see here that you have charge value as plus minus 5 into 10 power minus 6 coulomb, because it is in microcoulomb. So we will convert it into coulomb by multiplying it by 10 to the power minus 6. Okay, and here the distance to L is equal to 5 mm. For this distance, we already have covered that it will be taken as 2L or 2A. So here it is 2A or 2L, and it is given as 5 millimeter. Means 5 into 10 to the power minus 3 meter. Okay. So X is what here? X is here OX. Okay. X is here OX. What is OX? Like this. OX is this distance. Okay. And also OY. What is OY here? OY is for the second case. For this. What is second case? We will just study that also. Second, it will ask that a point Y that is 10 centimeter away from center O and a line passing through O and normal to the axis of dipole as shown. So it is a case of what? It is a case of equatorial point. So here it is a equatorial point and it is axial point. Okay. So in the first case, we have to find Ex and E. In the second case, we have to find Ey. So dipole moment will be what? Q into 2L. That is equal to 5 into 10 power minus 6 coulomb into 5 into 10 power minus 3 meter. So it will come out to be 25 into 10 to the power minus 9 coulomb meter. Okay. So this is the calculation of your dipole moment. So let's move to the next page and see what is the further calculation of this. Okay. Yeah. Till now, you have calculated the dipole moment of this question. Now, first of all, we have to find the electric field at a point x, that is on axial point. So here the like electric field is equal to 2px upon 4 pi epsilon naught into x square minus L square whole square. This formula I have already told you in the previous lecture, that this is the formula for the case of axial point field on for any dipole. Okay, so this is this formula you have to like remember this, and this is along bx produced because this direction should be in the like bx direction. And since L is very less than x here, so this is the case of like if you have the distance between two charges of dipole and it is very less than x distance. So therefore Ex will become what? 2p by 4 pi epsilon naught x cube, because L square term is neglected here. Okay. So substitute the value of your 2, and then p value we have calculated 10, 25 into 10 power minus 9, and 1 by 4 pi epsilon naught value is 9 into 10 power 9 upon 10 to the power 10 into 10 power minus 2 uh, whole cube. This is the value of x. Okay. So here you will got what? 4.5 into 10 to the power 5 Newton per coulomb. This is along px produced. Okay. So here x distance is 10. Why 10? Because it is placed like you can see in the question also that the charge is like, if you can see that electric field is like find out uh, on a place where the distance between X and O is like 10 centimeter. And we already told you that the distance should be like taken from the center of the dipole. If there is a system of two charges, we should always take the distance from the center of that dipole. So X is the point where we have to find the electric field, and the distance from center of dipole is 10 centimeter here. Okay. Similarly, for Y field, you have the distance from center of dipole is given as 10 centimeter. Okay. So let's see what is the value of Ey here. Ey formula is P by 4 pi epsilon naught x square plus L square to the power 3 by 2. Because we have already told you this is a case of equatorial point, and the formula for equatorial point is like this. Okay, it is a line parallel to BA, and it is along the line parallel to BA. Since here also L is very less than x, therefore we have Ey is equal to P by 4 pi epsilon naught x cube, because L square term is neglected, and then we will get this result. We have already covered this. You can see in the previous lecture. So here Ey will come like 25 to 10 power minus 9 to 9 to 10 power 9 upon 10 to the power into 10 power minus 2 whole cube. And if by simplifying it, you will get 2.25 to 10 power 5 Newton per coulomb along a line parallel to BA. So I hope that you can calculate it by yourself, the calculation part, and try to solve it by yourself again, and figure out that if you can do it or not by not seeing the question answer. Okay, so let's move further and cover the next topic. I should clear this. And okay, so the like third case of this electric field is for dipole, that is intensity of electric field at any point due to a short electric dipole. So till now we have seen the case of like what is the electric field due to any dipole at an axial point, that is on the axis of joining the two charges. And in the other case we have seen that what is the like electric field due to a dipole on an equatorial line. And equatorial line is perpendicular to the center, center of two dipoles and the line joining that center, and it is perpendicular to that line. So that is the case of like your equatorial point. But if we have to calculate any a field at any point that is random or general, so how to calculate that? So we will see here. Okay. So let's see here. Let K be here it is given that let K be any point which is neither on the axial line nor on the equatorial line. So here K is any point in the space, and you have the minus Q and plus Q charge here, separated by small distance of like you have 2A or 2P. You can write it like distance between two charges as 2a, you can assume it like this. Okay. And if you have a point like this is k point. Okay, so it is not at any equatorial point because it is not on this line, and not nor it is an on axial line. So it is not on this line also. It is a random point in a space. So if you join this point, or like if you join this with the center of dipole in this plane only, okay, not space, but it is in this plane only. So if you join this point like with the center of the dipole, because any distance of point where you have to calculate electric field, you must like take the distance from the center of the dipole, because dipole is a system of two charges, so you should not take the distance from any charge. Means that you can take the distance from minus q charge or plus q charge. That will be wrong calculation, because it is a system of two charges. So you should take the distance from the center of mass or center of these charges. So this distance will be your correct approach for this question. Okay. So yeah, we will join this point with the center of this dipoles, and let this center will make the angle theta with the line joining to the K point. Okay. So let P be the dipole moment of the short electric dipole and O be the midpoint of the dipole. So it is like O your midpoint, O is your midpoint here, and the dipole which have the direction from minus Q to plus Q. We have covered that the direction of dipole is from minus charge to plus charge. So here dipole direction is like this, and it is like P. Okay. So we will resolve these p components. Why we should resolve these p components? To make the calculation easier. Why? Because if you take the components of p, then it will make the situation of k point as a equatorial also and axial also. Why? They see here that if you have p direction is like this, and this is theta, and if you take the components of p via this theta angle, so if you take like this component, okay, so what will it become? It will become p cos theta in the direction of this uh, axial direction of this k point. It will become as p cos theta. Okay, p has two components, p cos theta in this direction, and other direction to the perpendicular of this p cos theta, that will be p sin theta. Okay, so this direction will become what? This will become equatorial, like equatorial point for this k, like k point. Okay, so p sin theta will become an equatorial for this k point, and p cos theta will become an axial component of dipole for this point. So electric field at k due to dipole moment p cos theta is given by k into 2 p cos theta upon r cube. Okay, why this formula is coming here? Because due to dipole moment p cos theta, that is like acting like a axial point for this. So we have already covered that if there is an axial point on, you have to cover like find out axial point electric field, any point on axis of dipole. So axial point the electric field value is what? 2p upon 4 pi epsilon naught r cube, that we have already covered, that this is the formula of electric field due to axial point, okay, of a dipole. But if it has like p cos theta here component, so we will add cos theta component also here. So it will become e like e of your yeah, just a second, E1. Okay, we have denoted by E1. So it will be like K into 2. P cos theta will be there, not P only, because the component P cos theta is acting as axial for this K point. So 2P cos theta upon R cube. This is the first electric field. Okay, and we have denoted it by K E1. So let's move further and see that what is the E2. That will be due to p sin theta component. And what is p sin theta component acting like? This p sin theta component is acting like your, see here, it is acting like your equatorial like equatorial point for this. Okay, P sin theta is equatorial for K point. So K point is also can be seen that it is equatorial to this dipole. So we will apply here equatorial formula. So yeah, we should like remove this. Okay, I have cleared the diagram like drawings, and now we will see that why it is the formula for like equatorial. So I already told you that the K point will act as a equatorial point for P sin theta component. So we will add here K. For equatorial, it was given in the previous topics that upon Kp upon R cube is the formula. But here P sin theta is the component, so we will add here P sin theta also. So this is the formula for your E2. Okay, and this is all of Km, which is perpendicular to cos theta, P cos theta. Okay, it is perpendicular to P cos theta. We have seen that. And resultant electric field will be what? E square will be that, and it will be E1 square plus E2 square. Why? Because E1 and E2 are perpendicular to each other. So the resultant will be equal to what? E1 square plus E2 square under root. And if you square both sides, then E square will be E1 square plus E2 square. That is given here. E square is equal to E1 square plus E2 square is the final result for your resultant electric field. Okay, so after squaring the both the components, you will get the calculation as like this. If you take this like this one first component and the second component, and you square and add them, so you will get like k into p by r cube into 4 cos square theta plus sin square theta to the power half. How this formula has come? You can I will tell you in the short that how it has come. You what you do, you should like take the common here. So if you take common here, two things like you have e square is equal to like this. Okay, take k common here and like p by r cube. Okay, p by r cube you can take common here. So p by r cube you have taken common here. So that will be square of this if you take common here. And then inside the bracket you have what? You have remaining cos square theta term. Okay. Plus you have also okay, here 4 cos square theta will be remaining here because 2 is also here. Okay. 2 term is also here. 2. So 4 cos square theta is remaining here. And here you have sin square theta term is remaining here. Okay, so if you take square root to both sides, so it will be what? It will come like kp by r cube into 4 cos square theta plus sin square theta to the power 1 by 2. That is the written here also. So what is written here? I have told you that how it has come after simplifying. Okay. So E will be equal to 1 by 4 pi epsilon naught T by R cube into root 3 square 3 cos square theta plus 1. How this come? Because we have taken one sin square theta plus cos square theta is equal to 1. Sin square theta plus cos square theta is equal to 1. So we have taken 1 here and plus 3 cos square theta will be remaining here. Okay. And root was already there. We have seen. So and that is the formula for electric field. You have to remember that it is equal to k into p by r cube into root of 3 cos square theta plus 1. Okay. Yeah. So if alpha is the angle between E and E1, then tan alpha will be equal to E2 by E1. Okay. So see here that how the tan alpha value has come. That is, we have calculated like this. Okay, that tan alpha is equal to 1 by 2 tan theta. So tan alpha is how we have calculated tan alpha here. See the figure. Tan alpha. Tan alpha is what? It is the angle between like E and E1. Okay. If you have like resultant of two additive field, E is like this in the upward direction, and it has an angle alpha with the E1. That is E1 is electric field due to your axial point. So if the angle between E and E1 is alpha, so you have tan alpha will be equal to what? It will be equal to like your yes, 1 second. Yes, tan alpha will be equal to what? E2 by E1. E2 by E1. You have already covered it in your vector vector chapter also that E2 by E1 is the formula for your tan theta or tan alpha here. So if you now substitute the values of E2 and E1 here, so E2 will be what? K into P sine theta upon R cube. Okay, and it is uh, your this is the value of E2, and what is the value of E1? E1 is we will write it in the inverted way because it is in denominator. So 4 pi epsilon naught or R cube upon 2p cos theta. Okay. So now the k and 4 pi epsilon naught this will cancel out. R cube will be cancel out, and p will be cancel out here, and you will be remaining with like tan alpha will be equal to 1 by 2 tan theta. So this is the relation we are getting here. You should remember this also. The tan alpha will be equal to what? 1 by 2 tan theta here. Okay. Yes. Okay. So so we have a case one. If K lies on the axial line of dipole, then theta will become 0 degree. Okay, if K is on axial line, that it is obvious that theta will become your 0 degree because it will come on the axis of your line joining the two charges. Okay, so theta will be 0 here. So your electric field will come like that 2p by 4 pi epsilon naught r cube, which is calculated in the case of like axial point field. We have already covered it, so it will come like this. So it is proved here also. And for like equatorial point line of dipole, then theta will become 90 degree. You can see here in the figure also that it will become 90 degree. So the electric field will come what? P by 4 pi epsilon naught r cube. That is also we have already covered. So here we have seen some points of this. Let's also try to see some examples here, and we should like remove the other drawings. Okay, so find the magnitude of electric field intensity due to a dipole moment this at a point distance that is equal to 1 meter from the center of dipole. When line joining to the point of center of dipole makes an angle of 60 degree with the dipole axis. Okay, so here we have given the p value that is equal to 3 into 10 to the power minus 4 coulomb meter. Okay, so we have to like see that what are the calculations here. R is here 1 meter and theta is given as 60 degree. This is a general case which we have just covered of derivation of that. And here E we have to find out. So we will apply the formula of like Kp by R cube into root 3 cos square theta plus 1. So after calculating it, you will get the answer of E as here the calculation is like done in the uh, one line only. So you can calculate it by yourself. It will come like 357 into point 357.17 Newton per coulomb. So that is the answer. It is simple question. You can like just substitute the values and get the answer. You have to just calculate the value calculation part. You have to do that. Okay. So let's move to the next topic or next page. What is in the next page? Okay. So the next topic is electric field intensity at any point on the axis of uniformly charged ring. So it is a very like important topic for your course also and also JEE exam also. So let's see that what is written in this topic for you. So yeah, just a second. Okay. So electric field intensity at any point Q on the axis is given by this formula. So how this formula has come, we will see here. Okay. Suppose you have a ring. Okay. Active field intensity here is due to a like a uniformly charged ring. So you have a uniformly charged ring here. Okay. So it has like all over it has a charge on its surface because it is a ring only. So the surface will be charged. There will be no charge inside because the ring has no inner surface. So the charge will be on the surface only. Okay. So yeah, if you have to find any like electric field on axis of uniformly charged ring means that the axis will be like this. So you have like I can tell you that if you have ring, then this is the axis. So like if you have ring and axis will be like this, passing through the center of this. Uh, like you can imagine it like it is placed in 3D and the axis is passing to the center of this ring. Okay. So if you have like this, so due to this ring, there will be like if you take any point charge at point C here, so the distance from this point, like O point, will be what? Root over your R square plus A square. A is what? The radius of your ring, and R is what? The distance between the center of ring and the point where you have to find the electric field. So this distance will become root R square plus A square. Okay. So now you have to calculate like if you apply here your like DE. What is DE here? Okay. So DE you will calculate here. So DE will be what? Like it will be equal to dq by r square for small charge. Okay. For small charge, we have to calculate it for small charge because you already know that the Coulomb's law is valid for only small like point charges, and we have to integrate it all over, and then we can get the result here. Okay. So here we have like two components of DE. So DE has here it is like for point charge DE direction will be like this because it is positive charge, so the direction of DE will be outward. It is like this for this point, and it has two components DE cos theta. Okay, DE cos theta is the one component and DE sin theta. Similarly, for opposite charge on this like this point, you have the this component. It is also DE, and you have this is equal to DE sin theta, and this is DE cos theta. Okay, so you are getting only d cos theta component as your net electric field, and d sin theta will not be counted here. Why? Because they are cancelling out by each component. If you take small charges, and d sin theta will cancel out here. So de cos theta is the net field. So I will calculate only de cos theta and integrate it all over the ring. So yeah, let's calculate it. So it will be dq by r square is what here? Root over r square plus a square whole square. Okay. And that's the value of cos theta. What is cos theta here? It is equal to r upon root over r square plus a square. Okay. So this is the value of your like electric field due to a point charge, and we will calculate it for whole charge. So it will be equal to what? We have to integrate it throughout 0 to plus q. Okay. So 0 to plus q. Why? Because all over the charges are plus q here, or you can say that small q is the whole charge. So 0 to small q is the whole charge. Okay. So we have to calculate from 0 to small q. Why small q? Because all over the charge will when we integrate it, all charges will accumulate combine and form whole charge on this ring that is equal to small q. So yes, after integrating it, what you get? Let's find out. So it will be equal to q. That is the integration of dq will be q. Okay, and r is also already there, and here k will be there, and like r square plus a square is there only in the denominator, and its power will become 3 by 2. Why 3 by 2? Because half power is there only, and like and it is like half power is here, and 2 power is like r square plus a square will be remaining here, because root r square plus a square whole square is there. So r square plus a square is there, and root r square plus a square is already there for some cos theta component. So this will be remaining in your dE. Okay, in the E. So E will be what, equal to QR upon 4 pi epsilon naught r square plus a square to the power 3 by 2, which I told you in the derivation here. So that is the result. How it is derived, I told you, and you can derive it by yourself also after this lecture, and try to solve by yourself. And this will be asked in your boards also, that how do this formula has come. So yes, just a minute, we will remove this part. Okay. So here it is given that Q is total charge, A is the radius of ring, and R is the distance of point Q, point O from the center of the ring. Direction is along QX. So direction of E is along QX, because the net component is acting like on this direction only. Okay. So yeah, we have covered this topic also. Let's move to the next topic. And what is that? That is dipole in a uniform electric external field. So we have to see that what is dipole in a uniform external field also. Let's find out that what is the in this topic. Okay. So if you place any electric dipole in any uniform external field, what you can observe? What should happen? So if you have two charges, minus Q, okay, plus Q, because dipole is only a collection of unlike charges, and they are separated by a small distance. And if you apply external external field here, E is here, that is uniform. Okay, so you can see that if the external field is here, so you already know that if charge is placed in any uniform field, or any electric field, it will experience a force. Why? Because there is a force which value is what? Whose value is QE. So it must apply on this charge also, or this charge also. So we will see that how it has applied. Considered an electric dipole consisting of two charges. So here two charges are there, minus Q and plus Q, and placed in a uniform external electric field of intensity E. So here an external field is there, that is equal to E, and the length of the electric dipole is 2L. The length of this dipole length is 2L. Okay. The dipole moment P makes an angle theta with the direction of electric field. So, the dipole is placed at an angle theta to the electric field. Okay, it is not placed in the horizontal or vertical shape like this, but it is placed at a tilted angle to this electric field. Okay, this is your minus Q, and this is your plus Q. Two forces F and minus F, which are equal in magnitude and opposite in direction, act on the dipole. What it says. Okay, so suppose that there is an electric field which is acting in the direction like this. So it will apply a force F on plus Q charge that will be in the same direction of electric field. If you have plus Q charge, that it will experience an force in the direction of electric field only. Okay, but if you have minus Q charge, it will experience an electric field electric force in the opposite direction. If electric field is there, it will experience an electric force in the opposite direction. So here F is equal to Q is will be in the opposite direction. So what you can inform from there, it is this is acting by a same force in this direction, and it is by same force in this direction. And if there is a system of anything, and one point, like one end is acting by a force, and that is making a couple with other force. Okay, if it is like making a couple with other force, then there is a moment is acting on this dipole. Okay, or you can say that it will act like a torque on a dipole. So yes, So here we can see that, okay, just a second. You can see that the net force is here zero only, because in the on this system you can see that this force has this direction and this has this direction, and both the magnitude are also equal. So net force on this system must be equal to zero. But there is a couple acting on this system, because these are not a different like system. It is inside this system only. These charges, these are not separated. So it is acting like a system, and a dipole moment, like this dipole moment is acting in this direction, okay, minus q to plus q. But it is also acted by a couple also, because the forces are equal in magnitude and they are acting in opposite direction, so they will form a couple here, try to rotate the charges system in like anti-clockwise direction or clockwise direction. Whether is how is the electric field here, so it will like try to till here it will try to move it like a clockwise direction. Okay, so the net force is zero since the two forces are equal in magnitude and opposite direction and act at different points. Therefore, they constitute a couple, which I told you that they will constitute a couple. A net torque tau acts on the dipole about an axis passing through the midpoint of the dipole. So there, a net torque will act on dipole. Okay, about an axis to the midpoint of the dipole. If you have a axis like this, so there is a net torque acting on this dipole. Okay. Now tau is equal to either force into perpendicular distance BC. Here, what is the BC is your perpendicular distance, and your force is any force you can take. If you take like this force, so it will have the distance this, and you have the torque value equal to QE into 2L sine theta. Why 2L sine theta? Because 2L has the component in this direction as 2L sine theta. So that is why QE 2L sine theta will be the torque value here. Okay. So the torque value we have calculated to QE into 2L sine theta. Let's move to the further point. What is that? So tau will be equal to PE sine theta. Why PE sine theta? Because Q into 2L is what? Your P value. That is value of your dipole moment. So PE is already there, PE sine theta. So here tau will be equal to P cross E, because PE sine theta is what? Your cross product value, and if we can write it like cross of P and E. Okay. SI unit of torque is Newton meter, and its dimension formula is ml2 t minus 2. This is the dimension formula of torque. You have already covered it in your 11th class. What is torque? So case one is there, if theta is 0 degree, then tau is equal to 0. Okay, that's like dipole is in stable equilibrium. So if theta is equal to 0 here, if the theta is like this, like it is straightly placed here, minus q and plus q. Okay, theta will become 0 here. Electric field is also in the this direction. So what will happen? Okay, this will have net force like this. This will have net force like this. Net force on the both the system of charges will be equal to 0, and there is no any type of rotation also, because force is like parallel to this surface, like length also, length of this dipole. So there will be no torque. So torque will be equal to 0 here. And the dipole is in stable equilibrium, because stable equilibrium is why is it stable equilibrium? Because if you try to tilt it, then it will come to this place only. It will not go farther away from that. Stable equilibrium is like if you disturb the system, it will come to its original place here. So this is the case of stable equilibrium. If theta is 90 degrees, then tau is equal to PE maximum value. If theta will become like this, so dipole is like this, minus Q plus Q, then your theta will be 90 degree, and your dipole, your torque will be equal to PE only, because L sine theta will be like this here. Okay, so it will become P sine theta equal to P sine theta. Okay, yeah, and sine theta will be what? Sine 90 is 1. So here you will get the answer as PE, that is the maximum value. Case third is theta is equal to 180 degree and tau is equal to 0. This is unstable condition because if you have like dipole is plus q is here, minus q is here, that is the case of 180 degree. So if you try to disturb the system, so if you disturb it like this, so it will be acted by this electric field, and it will like move it like this, and the whole system will rotate like this, and it will come to this space. So that is the case of unstable equilibriums, because it will, if you distance system, it will go away from its original position to next position. Okay. So I already told you that what is the case when the theta is 0, theta is 90, and theta is 180 degree. So let's move to the example 4 here. What it says, let's try to find out. An electric dipole consists of two charges of my point 0.1 microcoulomb separated by a distance of 2 centimeter. A dipole is placed in an electric field of 10 to the minus 5 Newton per coulomb. What maximum torque does the field exert on the dipole? So here you have to find the tau max. Tau max is when you have the sign 90, means that your angle should be 90 degree here. We already told you that if the theta is 90 degree, then tau is the maximum value. Okay, tau is the maximum value. So Q will be here point 0.1. Just apply the formula and find out tau maximum will be what? Here PE into sine 90, and that is equal to PE only. So PE you can find here. You will get the answer as 2 into 10 power minus 4 Newton per meter, Newton meter. Okay. So that is the value of your tau max here. Okay. So till now we have covered many topics today, and I hope that you got what are the like topics I have covered today, and that like some complex topics are also. So you have to like not only see this lecture, but you have to practice also some questions and try to do the derivations by yourself, because these are asked in your boards and school exams. So try to solve it by yourself only, and also solve other questions of topics which I have covered before. I will take like session of question and answer separately in like upcoming sessions of this chapter. So yeah, for today I think that should be enough, and we will try to start the other topic like work done on a dipole in a like uniform electric field. This topic we will cover in the next class, and I hope that in the next class the theory part will be maximum like covered. And if you have any doubts or any kind of query, you can comment in the chat box also, or you can ask with us. And if you want to like private sessions or one-to-one sessions with us, you can also tell us about that only. So yeah, I hope that you like the session. So thank you and have a great day.